Hey, just thought I'd give you a couple little hints before our test tomorrow. The first thing we take a look at is average value. So let's say we want to find the average value of this table here on 0 to 10. And let's say we want to use, let's say, trapezoids. Now, they're going to tell you either trapezoids or Riemann sums. So we want to find the average value. So the first thing you can do, you want to just set up your integral. So to get the average value, remember, this is our fave. It's just going to be 1 over 10 minus 0 from 0 to 10 f of x dx. Remember, we call it average value because I'm using whatever value they're giving me right here. In this case, it's f of x. If it's velocity, it'd be average velocity. If, for example, if this were velocity, I would find the average velocity, it would be velocity. If this was average acceleration, this would be acceleration, and this would also be acceleration down here as well. So we want to find the average value. And so there's my formula. To set this up, I'm going to clean this up a little bit. Now, to prevent what's called a linkage error, you want to put the 1/10 down here. And our integral here just says to find the area. So I'm just going to find the area. And they tell me in this case to use trapezoids. So I'm going to set my trapezoids here. 0, 1, 3, 7, 10. 0 has a height of 5, 1 has a height of 7, 3 has a height of 4, not drawn the scale, 7 has a height of 10, and 10 has a height of 15. So I am going to find the area of these trapezoids. So the area of trapezoid, 1/2 the sum of the bases times the height. So the first one, 1/2 the sum of the bases, 5 plus 7, and then the height, that's just this 1 over here, so times 1. Plus the second one, 1/2 7 plus 4. Be careful, the height here is 2 plus 1/2. The sum of the bases, that's 4 plus 10. And the height here is 4. Remember, they're not all going to be different heights. Plus 1/2. The sum of the bases, 10 plus 15. And the height here is 3. And that's it. Do not simplify, just leave it alone. The only thing I'll be careful of, sometimes students don't put the 1/10 here and they get it wrong because they forget the 1/10. Or the worst thing you can do is, oh, look, I didn't put my average value, the 1 over 10 here, and all of a sudden I put it here. Well, the question would be, where does that 1/10 come from? So you need to set up your formula and just put that the base, that 1/10 on the outside. That prevents what we call a linkage error. So this is the answer. That's our average value right there. Don't simplify, leave it alone. So let's take a look at another example here real quick. The second FTC. I saw this a lot on quiz. I see this a lot in quiz and test, where students, when they take the derivative, we want to find, let's say, find the first derivative. And let's say we want to find the whoops, sorry, that's terrible. We want to find the second derivative for g. Well, you have to establish this relationship. So we would say the first derivative, g prime of x, is, and we're just going to take the derivative of this. This becomes 2 plus, and when we take the derivative of our integral here, you don't have to show this step. You can go straight to your answer. When we take the derivative of that integral, our rule is simple. We're just going to replace each t with x. This becomes then f of x, like so. Now, we don't worry about the 3 because it's a constant. Its derivative will become 0. We'll see an example like that in just a few moments. All right. So if I want to now find the critical numbers, again, we've established this relationship. And now I can say, well, I want to find out where g prime of x is 0. Well, where does that occur? That occurs where f of x equals -2. To get the second derivative, we're going to take the derivative of course, of our first derivative right here. So the derivative is 0 plus f prime of x. And we've established that relationship. And now what we're looking to do here is to find our possible points of inflection. So to get that, our PPOIs, we're going to take our second derivative, which is f prime of x, and be 0 or d and e if it's a graph. And then you can find your possible points of inflection right there. But, so, when you're working this hint of second FTC, when you're working these, g of x is typically equal to some integral. The first derivative would typically be some x that we're just going to replace in. The second derivative would be the derivative of that f prime of x right there. You need to establish these relationships first. Don't establish those relationships, you lose a point or two. All right, so next one, let's take a look at another example of the second FTC here. So here we saw one like this on the quiz, and some of you guys had trouble. I'm taking the derivative. So I'm going to take the derivative of this. And my rule just says, look, I'm taking the derivative of an antiderivative. So, well, there's my derivative. It's on the inside. When I integrate it, that's going to give me some sort of function. But then I'm going to take the derivative, and that's just going to bring me back to the inside. So we said, for a shortcut, we can just replace each t with our variable here, sine of x. So this becomes the square root of the sine of x. However, I got to put into this dt as well. That is the derivative of sine of x. So far, we're going to get the square root of sine of x times the derivative of sine is just cosine of x. But typically, we don't have to worry about this bottom number because it's a constant. But in this case, it's not. So we have to use the FTC. Remember, the FTC says f of b minus f of a. So I have to now subtract that 3x as well. So that becomes the square root of 3x times the derivative of 3x. Same thing. And that's going to give me minus the square root of 3x, and the root of 3x is just 3. There we have it. Now, typically, we would have something more like this. 3 to sine of x, root t dt. Same thing, I will get the square root of sine of x times the cosine of x, just like we did above, but when I do that f of 3, well, remember, that's taking the antiderivative. That's my first FTC. The second FTC says take the derivative of that, and that just becomes 0. So this constant just becomes 0, so we don't have to worry about it. So we just left that. All right, hope you enjoyed the video. We have a test coming up. Please study for it. I'll see you guys tomorrow. Bye.